Hello everyone, we are Team C242-PS025, and today we are excited to present the result of our Capstone project, namely BinBuddy, one scan away from a greener tomorrow, an application designed to educate households in Indonesia on how to manage their waste effectively. First of all, let's meet the members of our team. Tamara, Alicia, and Ken are part of machine learning, Design are part of cloud computing, Leslie, Albert, and Alpine are part of mobile development. Each member brings unique expertise to this team, contributing to the success of this project.
Okay, before going on to our project's overview, feel free to check our GitHub repository using the link or scan the QR code below. Now, going on to why BinBuddy was made, there are two major things driving this. Cited from official resources, per 2024 reports that Indonesia generated around 32 million tons of waste, with 11.3 million tons left unmanaged. And most of these waste are generated from households due to poor sorting practices. This points out the need for technology to achieve a more efficient waste management system. So in context, our project BinBuddy is trying to answer one question in mind. How can we address unmanaged household waste and poor sorting in Indonesia while promoting a sustainable waste management system through technology? Our project aims to achieve three things. One is to educate users about proper waste classification and recycling practices. Two is to spread information and awareness using tips and articles. And the third one is to help users to find the nearest waste disposal location around them. Now going on to machine learning implementation in BinBuddy. We built our ML model for image classification entirely using TensorFlow framework and Keras API, utilizing transfer learning and fine-tuning CNN models using weights from the famous ImageNet 1K dataset. We use Python as our programming language with GitHub and Google Drive for storing notebooks and models. Our primary IDE is Google Colab to address limited local computing resources. Our dataset includes 15,000 Kaggle-sourced image, clean and balanced into 10 classes. The data is split into 70% training, 20% validation, and 10% testing sets. The model is entirely cloud-hosted. As shown in the pipeline, users select an image from the gallery or camera, upload it into our cloud services where pre-processing and inference occur, and then results are stored in Firestore and Firebase. We evaluated MobileNet v3 and EfficientNet v2 based on validation accuracy, usually higher is better, validation loss, usually lower is better, and model size in bytes, smaller is better. In the end, we deployed MobileNet v3. We also did 30 real-world camera tests, and we achieved 76.66% accuracy. Two classes were problematic, but it's acceptable given the dataset consisting mostly internet-scraped images. To enhance performance, we plan to add more camera captured data from real use cases.
Okay, library tools to implement BinBuddy. We use Google Cloud for scalable solution, is Cloud Run and Cloud Storage. Fast power our machine learning API, while Passman help test and debug endpoints. Firebase ensures secure authentication and user data management, creating a robust and user-friendly application. Google Cloud Processing Architecture, Android user upload image, processing by a flash-based machine learning API on Cloud Run, containerized with Docker and managed via artifact registry. Cloud Build handles deployment. Cloud Storage secure image storage, and Firebase manage authentication. This architecture ensures scalability, security, and efficiency for a seamless user experience.
Next, let's explore the result. We use Cloud Run, Firebase, and Storage to efficiently and securely power our solution. Cloud Run and Storage result. We use Cloud Run to deploy our vision learning model and backend API via Google Cloud Platform. Files are stored securely using Cloud Storage. Firebase result. We use Firebase authentication, file store, and storage for image classification. API documentation endpoints. We create 6K API endpoints. First, sign up, allow new user registration. Login generates a token for classification access. Classify provides prediction result. Save classify lets user save classification result. Get data retrieves all save classification. And the last, delete history. Delete specific records by document ID. These endpoints ensure seamless data classification, storage, and management.
Okay, move on to the mobile development implementation. The main tools and libraries that we use are first Android Studio as an IDE, next Google Maps SDK and Places API for web services, then Figma to create UI design and prototyping, Retrofit to handle HTTP requests to our API, Metro Design to create user-friendly and consistent interfaces, then Glide to manage and display images from our API. Next is workflow. Essentially, for this project, we use several URL API endpoints that we created, such as for classification, login, sign up, and performing create, save, and delete operations on user classification results. Additionally, for the Maps feature, we use the Maps SDK and Places API. Our responses from the web services are then managed and displayed in the app to the users. Okay, before moving on to our results, let's take a look at two similar projects that we have found. Two of them basically is an app that can help users accurately identify the type of waste and provide detailed information and disposal recommendations. The first one is EcoSort. The missing elements are non-result saving functionality, limited additional information resources such as article, and no nearby waste bank location finder. And the second one is Bingo. The missing elements are no result saving options, no gallery image selections, and no nearby waste bank location finder. After we identify what are missing from those projects, we try to fulfill the missing elements from those projects. And here are some improvements that we have made so far.
Okay, thank you, Alvin. I'll continue with the UI design and final result, starting with the register page. On the register page, new user can get started by providing their name, email, and password. The data is sent securely to the API and stored, ensuring a smooth onboarding process. After successfully registering, users are directed to the login page to access the app. On the login page, users enter their registered email and password, then press the login. Webrover sends the data to the API for the authentication, and once validated, the sessions remains active until the users log out. After logging in, users land on the home page. On the home page, users can tag or select a picture for waste classification, then press Classify Now to get a quick results. Results are detailed on the detail page. On the detail page, users see the classification score and item type, a save button to store the result, and additional insight by swiping up. Next, we have the save page. This page display a list of saved results, including the item type, score, and date. Users can tap show detail to view more information. On the map page, for finding nearby waste bank, the map shows the user's current location, nearby waste bank with the marker, and then tapping a marker provides the address and contact option, such as a call, message, or WhatsApp. Lastly, the account page lets user manage their profile. Here, users can view their name and email, log out securely, clearing all the session data. That wraps up my part. Thank you for your attention.
Our target market is dispersed and inclusive. Geographically, we focus on the individual aged 18 and above from any location. Our audience include homemakers, students, environmental activists, and recycle entrepreneurs of all gender. In terms of roles, we cater the individual users, community members, and professionals. Behaviorally, our users are passionate about environmental sustainability and often embrace technology. Psychographically, they value sustainability, seek intuitive tools for waste sorting and education, and enjoy environmental activities and continuous learning. This makes our app the perfect solution for their needs.
Why does our target market need our solution? BinBuddy empowers individuals, communities, and professionals with tools and resources for effective waste management, reducing pollution, and promoting a greener future. We provide data-driven insights, including waste descriptions, recycling methods, and disposal tips to help users manage waste responsibly. BinBuddy also supports government efforts by promoting waste segregation, recycling, and aligning actions with environmental goals. Our solution benefits multiple stakeholders, such as individuals, to simplify waste sorting and raises awareness, recycling businesses to enhances workflow efficiency, governments and agencies to provide data for policymaking, also activists, developers, and investors. Our marketing strategy focuses on digital marketing through social media campaigns, gamification, and webinars, community engagement via environmental events and online features, and targeted advertising using Google Ads, Meta Ads, and social media. We also collaborate with CSR programs, NGOs, local governments, and schools, supported by a referral program and a brand ambassador program to expand reach and engagement.
Now let's move on to the SWOT analysis. For strength, BinBuddy stand out with innovative waste management solution, automation features, adaptable data sources, and educational benefits, making both practical and impactful. In weaknesses, we identify challenges such as limited accessibility, technology limitation, and the cost associated with development. As for opportunities, there is a chance to leverage technological innovation with partnership, government communities, and collaborative recycling communities to scale the impact. Finally, in threats, we face competition with similar apps, potential user resistance, and limitation in existing waste management infrastructure. That's a summary of the SWOT analysis for BinBuddy. Now let's move on to the next part of our presentation. Here is a 6-month plan to locally deploy BinBuddy effectively. In month 1, we focus on finalizing preparation, it's already absolutely ready, and identifying target communities. Month 2 is dedicated to pilot testing and selected communities to get evaluate feedback. In month 3, we refine the app based on feedback, making necessary improvement and adjustment. Month 4 marks the first local rollout where we introduce the app to new communities and conduct training session. Month 5 is all about evaluating early results to measure the app initial impact and identify areas for improvement. Finally, in month 6, we expand the app to other regions while optimizing its features for better performance. We apologize for any mistakes during our presentation and value your feedback. Thank you for your attention, and let's work together for a greener tomorrow.